Greetings to all of you. In today's session, the topic is regarding intermediate chemistry will be helpful for the international standard of entrance exam or else any competitive exam you are seriously aspiring for. India level JE advanced and JE mains, if you are preparing for any IIT or NIT stream, this is the technical domain. Need chemistry for medical entrance examination across India. PS and AP what MSET examination for engineering stream, that is again technical stream. In addition to all these, if you're aspiring for any government examination, you're writing any government examination regarding your government career, government job. So in that condition, general studies common question paper will be offered. So in that question paper, general science is the commonly available questions from where you can find chemistry, physics, and all science related questions. So the kind of session what we are discussing is very much fetching for your preparation. Let's enter into our today's concept. Here, explain the name of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. So IUPAC gave certain guidelines in order to assign name for the compounds. In this, the compound is taken like this much long chain with the bromo, methyl, chloro side chains. Okay, so these substituents, if located on this organic moiety, how can we assign the name? In order to name that one, here we need to follow three rules, right? So first of all, choose the longest most substituted carbon chain. So here you can go for the carbon chain in this manner, or else carbon chain in this manner, or carbon chain in this manner. So the condition according to IUPAC rule 1, what they are saying, so whichever the way you are going to assign numbering to the carbon atoms, that should be longest and that should be considered as the parent chain. Okay, for that purpose, here you have two provisions. Either from right hand side you can start numbering, left hand side you can start numbering. So if you are going to start numbering from right hand side, 1, 2, 3, 4, 5, 6, 7. This is the way you can go with. If you are starting from left side, 1, 2, 3, 4, 5, 6, 7. This is the way, right? So both the provisions you have, you are trying to get all the possibilities, whatever you have. After getting both the possibilities, you have to go for the compulsory condition where the numbering in certain regulations, certain rules as per the IUPAC. After applying the first two rules, we need to go for alphabetical order. B for bromo, C for chloro. So that obviously numbering will be started from left hand side. 1, 2, 3, 4, 5, 6, 7 will be the order. So that the correct name will be, the correct name for the compound will be 2 bromo, 6 chloro. And being it is the single bonded compound, we can say saturated compound and made up of 7 carbon atoms as a parent chain. Heptane will be the name. 2 bromo, 6 chloro. Heptane is the name of the compound, right? So let me repeat the name of the compound. 2 bromo, 6 chloro, and here another methyl is there. What is the location of methyl? Methyl is located on the 5th carbon atom. So after chloro only we have to write a methyl. Why we have to write methyl after chloro? Complete name will be assigned as, here on the second carbon atom you are recorded with the bromo, so the 2 bromo, and 6th carbon is having chloro, so that 6 chloro, and 5th carbon is accompanied with methyl, 5 methyl you can write, and heptane is the parent chain, being it is 7 carbon length, so that let me mention heptane. Okay, so here 2 bromo, 6 chloro, 5 methyl heptane. Here, in order to assign this name, we have to follow these many rules. First of all, you have to choose the correct chain of carbon which should be longest length, right? After that one, you can go with all possible numbering system, right? Whenever you are going to choose the possible numbering system, after that you have to go for the proper numbering, in which direction you have to go for. So in order to get that one, we have to choose alphabetical order, and moreover bromo atomic number is larger compared to chloro, so that In both the constraints, you can start numbering from left hand side, so that the correct name will be 2-bromo 6-chloro 5-methyl heptane. This is the way we can answer IUPAC nomenclature for the given compound. This is regarding question number 1. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education, which diagram shows structure of an alloy, right? Here these many compounds are there, we need to go for alloy. We have to distinguish alloy among all the 4 options. The correct answer will be option number D, right? So in order to mention what is alloy, what is pure metal, first of all we have to know alloy and pure metal. Pure metal is nothing but any metal having repeated combination of same type of atoms. Metal or non-metal which is composed by only one type of atoms is called pure in form, right? Alloy is more than one component got mixed up. It is the hybrid of more than one element or one metal, metal and non-metal, non-metal, non-metal. So many possibilities we can find for alloy. Let me give the example for alloy. Steel is the alloy. Steel is the alloy of iron combined with iron blended with carbon atoms, right? So this is the way alloy can be manufactured in order to enhance their mechanical strength, their tensile strength, their hardness, their texture and durability. So everything got enhanced, and their finishing, everything got enhanced by the addition of certain kind of materials into that. That is called a blending process, so that we will get the alloy of all required capabilities. So that alloy formation is most important, right? So these many compounds are there. Let me show how can we say D is the correct answer for the alloy, right? In order to explain that one, first of all we have a what chemical structure for the compound where hexagons are located, and in between you can notice like this. If you clearly observe, each atom is surrounded with 4 bonds. This is the kind of tetrahedral representation. Instead of hexagons, we have to keenly observe each atom surrounded with the 4 atoms in the tetrahedral corners. So repeated combination of such tetrahedrons are shown over here. This is a perfect geometry accorded for diamond. Diamond is the hardest material known in the nature, right? And this diamond is composed purely by the carbon atoms. All the repeated atoms are carbons, and moreover all are bonded by covalent bonding, right? So it is the covalent solid made up of repeated combination of carbon atoms, and this is said to be allotrope of the carbon itself, and it is the crystalline form, more hardest material in the nature, right? So that we have one kind of proverb: in order to cut the diamond we need to go for another diamond itself, no other material is able to cut. So that is the general assumption, being it is very hardest material, we can go for why it is more hard, because if you see, it is the kind of web. So it looks like a web where the repeated combination of carbons are possible in all tetrahedral geometry, and this will be extended in all possible dimension, 3-dimensional representation you can notice, and purely made up of carbon. And we can say it is not the alloy. Alloy must be blended molecule. It must be a kind of more than one atom, but diamond is made up of purely carbon, so that it is not alloy, rather it is a pure one. And if you go with second, if you observe all the atoms are resembling one with other. All the atoms are resembling nothing but all are similar. So I'm taking the example for that iron atoms when considered, being iron is the metal, and moreover, though periodic table, if you observe the entire periodic table, if observe, so around the 70 to 80% elements in the periodic table are said to be metals. Among all the metals known to you, iron is the widely used metal among all the known one, right? Because iron find a versatile applications. If you use construction, you can use steel that is made up of iron. If you use human body, in human body also we have a blood, in that also iron is there. If you go for railway track manufacturing, there also iron found. Railway bogies made up of iron. Building construction, bridge construction, cables construction. Everywhere you are using iron. So that iron is most widely used metal all across the world, we can say. And this is the repetition, being it is a solid metal, all are arranged in a very highly closely packed regular arrangement, you can notice, so that it is the kind of metal. So this is the also the part of what, pure metal rather than alloy. We can't say it is the alloy must be mixture. So this is the pure metal. Move on to third geometry is assigned for this kind of representation is assigned for graphite. Graphite is made up of carbons again. All the carbons are hexagonally packed. This hexagon means six corners are available, and another hexagon. This is one layer, and another at the bottom also you can find same hexagonal layers, and both hexagonal layers are interconnected by such a dotted line bonds. These dotted line bonds are nothing but weak forces. So these forces are designated as van der Waals forces, right? Because of these forces only all layered structures are possibly connected one with another, right? Whenever you're applying the force, so that these dotted line bonds will broken, so that one hexagon will slide over another hexagonal layer. Hence we can use graphite as the best lubricating material in the automobiles, right? So in the machinery, heavy machinery, wherever friction available in that condition, in order to avoid the friction, we can use this graphite as the efficient solid lubricant, right? Because of such a kind of sliding nature, such a kind of weakly available forces in between two different layers. And moreover, pencil lead is also made up of that graphite, made up of carbon, and this is purely made up of carbon. You can find all the carbon layers only, so we can't say this is also alloy. And move on to in either alloy. What is alloy? What is pure one? Pure metal, you can find all the lobes are made with the same colored and same size, same dimension, same nature, same applications. So whenever force applied, this is the kind you can notice. We are not supposed to assume different nature, different properties for these, because all are resembling one with other. This is said to be pure one. Whenever you go for alloy is the combination of more than one type of material, that maybe a kind of metal, non-metal, metal, non-metal, non-metal, whatever the kind it might be, but a blending of one material with another are required. Pure metal can be mentioned with the blue lobe, and another element if added, that is mentioned with the green lobe, so that we are going to blend, so that alloy formation is possible. Among the given options here, you can clearly notice all the lobes are smaller, that means all are equally sized, but one of the lobe is larger than remaining, so that we can say this is some other a new material got added over here. So it is the simplest example for an alloy. This is the way we can answer. If you go for analysis, how structural analogy will be there, how can we arrange the atoms in our solids, liquids, and gases? And moreover, in case of solid, arrangement will be multiple ways. So in that arrangement, how can we categorize crystalline, amorphous, pure metal, alloy, and these many possibilities come into picture, so that we should aware about the concept in a deep learning manner, so that we can understand and we can easily answer such questions. For question number 2, option number D will be the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2021 question paper and paper 1, from which the question was gathered. The maximum number of possible isomers, including stereoisomers denoted with enantiomers, diastereomers, like that. Optical activity, if there, here stereoisomers will play, which may be formed on monobromination of 1-methyl cyclohexane using bromine under ultraviolet light. Being it is ultraviolet light, reaction is a photochemical in nature. Under light conditions, if you are performing any reaction, we can say photochemical reaction, photo-induced reaction as well. So they are saying 1-methyl cyclohexavanine. 1-methyl cyclohexavanine was taken and added with bromine under H nu conditions. UV light, nothing but light. Whenever light irradiated, how many possibilities you are having to substitute this bromine? You can add bromine at this position. This methyl will be one of the hydrogen got substituted with methyl. Being photochemical entire mechanism will proceeded with the free radicals. Homolytic fission of the bond is accorded so that we will get such a dotted bonds. Dotted electrons are denoted as free radicals. Fine. So whenever bromine under photolytic conditions added, one of the hydrogen got removed and we will get CH2 free radical. So this is called what? Allyl free radical, double bond in conjugation with a free radical called allyl, more stable one. And here this is one possibility, so that it is mentioned one. And in case of second one, if you see, from this source also hydrogen can be subtracted whenever hydrogen removed, so that you will get a free radical. But this free radical, whatever generated, is optically active. That means chiral in nature. What is meant by chirality of the carbon? Any carbon is surrounded with 4 different functional groups is called chiral in nature. This side we have C double bond CH3, this side we have CH2, and another side we have H. So that all different are there. So this is a chiral. Chiral always gives rise to mixture of 2 rather than 1. Okay. So this the possibility is bromo will come towards the Viod with the wedge bond in one possibility. In the second possibility is the same bromo will go back with the dotted line bond as well. So that you can see here 2. 2 denotes what? It will give 2 isomers. And another also we have the same condition but in opposite direction. Here also this carbon is said to be chiral. Why it is chiral? 4 different atoms are functional groups around the carbon is said to be chiral, and whatever compound coming will be optically active. Optically active means whenever it placed in the plane polarized light, it will blend or it will reflect. It will deviate the light either towards right hand side or left hand side, and this also said to be chiral carbon atom. Hence you can get 2 isomers. And here another possibility, at this carbon you can get free radical, gives a 2, again 2 isomers are there. And this is the carbon said to be vinylic carbon. If you are getting this kind of dot means free radical, here the possibility will be cis strands. This is said to be geometrical. Whenever any arrangement of the functional group around the double bond is mattered, then we have to go for the geometrical isomerism. Either you can say cis strands or else EZ. That kind of geometrical isomerism, 2 isomers are possible, so that mentioned with the 2. And if double bond is there, here is one of the electron which is exactly identical with this one, so that it is mentioned with the interconverted one, so need not to mention. And here another possibility, if you are shifting double bond over there and here is the free radical, again it is said to be chiral carbon. Chiral carbon will give 2 optical isomers. Okay, if you count all, 1 plus 2 3 plus 2 5 plus 2 7 plus 2 9 plus 2 11, 11 plus 2 13. 13 possible isomers you can notice. 13 is mentioned over there. So in order to answer such a question, whatever name mentioned, first of all, we should have the fundamental idea how to draw its chemical structure. In order to do this, we have to go for IUPAC nomenclature. 1-methyl cyclohexane. What does it mean? Cyclohexane means what? A cyclic compound can be taken. One double bond should be introduced and one methyl must be there. And what they are treating? They are treating with bromine. They're treating with bromine under what? UV conditions, light conditions. Whenever this is the case, you are doing how many possible cleavages you need to observe. If you see the possible cleavages, so that you can go for how many possible isomers we will get. In order to answer this question, first of all, we have to know what is optical activity, what is chirality, what is geometrical isomerism, what is optical isomerism, like enantiomers and diastereomers. If you know all these parts, then only you can 100% answer this simple question, right? So this is the way. If you go for all you what chemistry is a multidisciplinary, it can be connected with multiple ways. So if you want to answer one question, you should have the idea about these many, then only it is possible to get the answer. So multidisciplinary in nature, fine. So that the correct answer will be 13. And for question number 3, 13 is the correct answer. It is given from especially organic chemistry, and moreover we can say stereochemistry part, right? And moving to question number 4, again it is collected from JEE Advanced 2021 question paper, paper 1 question it will be, right? In the reaction given below, the total number of atoms having sp2 hybridization in the measured product P. So uh, here it is a kind of logical question where you have to identify what is the product P. After getting product P, you have to analyze what is mean by sp2 hybridization, what is sp3, what is sp. So again it is an interrelated question. If you know the answer till P, if you are not able to get what is sp2 hybridization, there is no way to receive the marks. No, that's the reason why elaborated and extensive knowledge gaining is more important. Then only we can answer this kind of questions more logical, we can say. This is the kind of 8-membered ring, this is the 5-membered, this is another 5-membered, and in the 8-membered ring you can see two double bonds are located, double bond and another double bond is located. The reagent we are adding is ozone under excessive condition. Excessive ozone will be added over there, then zinc water will be added. This is a kind of hydrolysis we can say, and another is called hydroxylamine. NH2OH is called, this is the reagent hydroxylamine. Okay, so the reaction it seems to be somewhat simple reaction only, but analyzing the expected answer and followed by connecting with another question what they are asking is more logical in nature. Question criticality is simple, but we can say more logical. Fine. So this is ozone. Ozone stands for it is the allotrope of oxygen. Triatomic oxygen will be there. It is somewhat less stable in nature and more reactive in nature. It find applications in our daily life, and even in the universal protection we can see ultraviolet radiation can be prevented, and even in the synthetic organic chemistry it is the precious reagent. What purpose? In order to identify the double bond location, whenever ozone is added, the double bond got cleaved, and here whatever carbons connecting double bond will turn into diketone or dialdehyde, dicarbonyl compound. Let's see. Here the double bonds, ozone treated. Ozone is very selective for the attachment or cleavage of the double bonded carbon only. This is very selective reagent in the qualitative analysis to count the number of double bonds present in the compound, or else to identify unsaturation in the compound, right? So whenever ozone is added, this pi bond is cleaved, and subsequently double bond is formed in the presence of zinc and water. This is the hydrolysis. Okay, addition of ozone followed by hydrolysis gives rise to double bond or double bond. And we have another, so that here also you can get double bond or double bond. Tetraketone molecule is generated. This is called tetraketone. If you observe these many rings, how many are there? 1, 2, 3 are there in the starting material. Whenever ozone treatment done, entire ring was cleaved, so that the molecule became like a puckered monocyclic only. The entire one will be one ring, and this is said to be puckered one. It is not exactly a kind of sphere, and we can say puckered ring, right? And we treated with NH2OH, which is called hydroxylamine. Hydroxylamine is very selective reagent for what? It is the ammonia derivative. Ammonia derivatives are hydroxylamine, hydrazine, phenylhydrazine, semicarbazide. All these are the derivatives of ammonia and are selective for identification or characteristic reactions of carbonyl compounds. They will condense. They will participate in the condensation reaction with the carbonyl compounds. Wherever double bond is there, that will be condensed with this one. Water will be removed and you will get double bond NOH. This is called oxime. Any carbonyl compound treated with hydroxylamine, the product is designated as oxime. Here, oxime. How many ketones are there? 4. Hence, we are using excessive reagent. Hence, 4 oximes will be generated. This is about what chemical reaction part. We purely gone with the chemical reaction part. Now, we have to go for analysis of sp2 hybridization. Here, a simple trick regarding sp2 hybridization is any atoms which are joined by the double bond are participating in a sp2 hybridization. This is very simple trick we can go. Singly bonded atoms are sp3 hybridized. Double bonded atoms are sp2 hybridized. Triply bonded atoms are sp hybridized. This is the simple trick we can go for. Being competitive exams are time bounded, we have to go for some logical tricks as well. So that here double bond is there. So carbon is sp2, nitrogen also sp2. This nitrogen sp2, carbon sp2, 4. This carbon nitrogen sp2, 5, 6. This nitrogen carbon sp2, 8. So here 4 oximes we have. Subsequently 8 atoms are participating in sp2 hybridization, so that 8 is the right answer. Number of possible sp2 hybridized atoms are not carbons. If they are asking only carbons, we should be more careful regarding answer. So if they are asking only sp2 hybridized carbons, the value will be halved. Carbons are 4, nitrogens are 4. So that entire sp2 hybridized are 8. So the correct answer for question number 4 will be 8. Move on to question number 5. Question number 5 is collected from Telangana Gurukulam Degree College Lecturer Entrance Examination. And here we have carbon-carbon bond. And this is the kind of representation, three-dimensional representation of bonds. Three-dimensional means one of the bond is inclined towards the viewer. Wedge bond we can say. Dark line bond is called wedge. And dotted line bond is called, that is away from the viewer. Right? So here one of the methyl towards the viewer, one of the methyl away from the viewer. Here also the same condition. And here is the reagent you can notice Se positive, Et O negative. Right? Et for ethyl, Se for selenium, and selenium cation it must be. Right? So this is the way you're going to react with the heat. Heat reaction is called pyrolytic conditions. Any reaction carried under thermal condition, high temperatures, which are called pyrolytic conditions. And upon heating, most favorably, they will participate in a elimination reaction in suitable way, so that there is a formation of double bond. Double bond is generated, and selenium EtOH, here H, here O minus. This entirely eliminated as ethyl selenium hydroxide. So here the final product is double bond. So this is the chemical reaction they provided. We have to assign suitable name for this reaction. Pyrolytic anti-elimination. Anti-elimination, syn elimination. Pyrolytic stands for what? Thermal conditions. Are you applying heat or not? Obviously, we are applying, so that pyrolytic is the right pronunciation. Anti-elimination is nothing but if two departing atoms are going from two different phases, up and down, front and back. So this is the way you are removing. That is said to be what? Anti-elimination. But here in the molecule, H plus is coming from one side, selenium also coming from same side. So that we can say both are departing from the same plane, same direction. This is not anti, rather it will be syn. Okay. And E2 elimination. E2 elimination stands for what? Wherever elimination is carried under strong base, we can say. Here base is not mentioned. And bimolecular. So here only one molecule is there. We can simply discard this one. right? Bimolecular elimination reaction, they are saying only one molecule is participating in elimination, so that it is not yet all the correct answer. Then even CB mechanism, even CB stands for what? Unimolecular. Unimolecular means one molecule only we are using, that is correct up to certain extent. CB for conjugate base mechanism, first of all H plus will be removed, later on remaining part will be departed. So whenever H plus removed, we will get a base, that means negative charge, which is called conjugate base. Okay, but the reaction is not proceeding with such a removal of H place followed by any other bulky group. Rather, it will participate in a cyclic transition state that is purely designated as pyrolytic syn elimination. Syn means what? Same side. If you're eliminating two departing functional groups from the same side under high temperature condition, pyrolysis stands for high temperature, thermal conditions are provided. So this suitably apted for the given chemical reaction, pyrolytic syn elimination. Let's see, how can we see? Whenever selenoxide elimination, selenoxide means a selenium with the oxide substituent on there. This will participate in this bond is moving slowly towards the carbon-carbon double bond, and this bond is departing like this, and oxygen is abstracting this H plus. This is the way a 6-member transition state you can notice, and the transition state is possible whenever you are eliminating two departing functional group from the same side. If both are opposite, it is not at all possible to remove by transition state. Transition state is possible whenever you are removing from same side, so that we can say syn elimination. So simply two groups, one bond formation, one bond cleavage possible simultaneously, and you will get a double bond by removing this selenium hydroxide. Let me say, pyrolysis stands for any chemical decomposition, breaking of bonds under elevated temperature conditions, right? Any chemical decomposition accomplished by elevated temperature, high temperature, we can say it is pyrolysis. And it can be takes place with the cyclic transition state. If you see clearly, notice that cyclic transition state is possible over there. And being it is a syn is a stereochemical relationship between the hydrogen and leaving group departing from the same side. Incipient double bond, in order to receive this double bond, both are coming from the same side. This is the way we can answer. The given decomposition is the part of pyrolytic syn elimination. For question number 5, answer number 3 will be the correct answer. Move on to question number 6. Question number 6, again the part of organic chemistry. A suitable reagent and the synthon for the synthesis of target molecule. This is the final product we need to synthesize. In order to cook this product, what ingredients we have to take as the starting materials? One must be a synthon. One must be a starting material. In others are said to be reagents like this. Synthon will be the starting material itself. So these many get combined so that this is the product we will get. How can we say these are going to be combined? Simply just to count the carbons in the product and compare with the carbons in the starting material. Among all, only the one is mapping with this one. A simple trick to make a suitable answer over here, need not to go for the mechanism other than this one. So a simple fundamental you need to go for, just to count a number of carbons over there and a number of carbons in the given options. Only option number 2 is exactly mapping with this one. And let's see the exact mechanism. Whenever these are the expected starting materials in order to synthesize the final product, ethyl bromide, this is said to be ethyl bromide, will participate in the bond formation with the triple bond, and this triple bond, only one pi bond will involved in a new bond formation, leaving another pi bond with that carbon only, so that in the product one of the double bond is still there. Triple bond now consists to double bond only, so that you can make a move of only one pi bond like this, And this carbocation is electron deficient, no, need electrons. That's why it is taking electrons from this carbon atom. This is the way you are going to combine all three starting materials in a synchronized manner. Synchronized manner stands for any kind of addition or reaction where feasibility is more, extent of reactivity is more, that is called synchronized arrangement. Okay, so that we are going to treat all these starting materials in a required manner, required orientation, so that this will be the product obtained, right? So here the target product is obtained by ethyl bromide, acetylene, and this is called the ethyl alcohol only, but we are having alpha beta. So beta ethyl alcohol beta carbocation. So this is about question number 6. Question number 6 is correctly answered in the option number 2, right? By this, we entirely completed the session and we covered with the different dimensions of chemistry, which are very important for competitive examination context and also entrance examination. And definitely if you are watching this content, you will get more inspiration towards the preparation of chemistry, and you will reach out whatever you are aspiring for. I'm sincerely requesting to like the channel, comment which is really important for you, share with the aspirants who are serious for the examinations, and subscribe the channel to receive more such kind of content, important content we can say. Thank you one and all for your patient listening. Thank you.